Did you know you can directly manipulate images in Godot? This lets you do some very interesting things, so follow along as we learn how to use them and make our very own canvas paint system. Let's start by adding a sprite 2D and move it to the side so we can see the whole image later. Now let's create a script and get started. On the ready function, we first need to instantiate our texture. We can do that with the image texture type by calling .new. Godot typically displays images by using the texture 2D type or any one of its inherited types. But that is not the image itself, it only holds the image data. And the image texture class is one that lets us set the image ourselves. So first, let's create our image with image.createEmpty. To create an image of 256 by 256 with no mipmaps. And the last and most important parameter is the color format. There are a range of formats you can use here. But we'll use the RGBA8, which means the RGB values plus alpha, each with 8 bytes of data, the default format of many images. If we take a look at any images in Godot, it defaults to use the DXT5 RGBA8 format, which is the compressed version of the RGBA8. But now that we created the image, we just need to give it to the texture, with texture.setImage, a special function of image texture. This will create a new image data in the memory for the texture. But if we run the game now, we still have nothing. An empty image is just empty. So we can use the image.fill to give it some color. And now we got our white square. But let's try to fill it with green after we set our image. And now nothing happens. That is because the image is not a direct reference to the image data inside the texture. You need to call texture.update and pass the image again. This will update the image color data to the texture. Do note that you need to call setImage first to actually create the image. The update function only updates the image inside the texture. But there we go, we updated the image. Instead of doing all that, there is also another way we can create images. We can use the image texture.createFromImage and inside here call the image.createEmpty. If we create our texture like that, we can then get the image with texture.getImage. But like before, this is not a reference for the image, but a new copy. So we still need to call texture.update like before. Now that we learned how to create images, let's see what else we can do. There are a few ways we can manipulate images. We can get any pixel color with the getPixel by giving it an X and Y, or a pixel V by giving it a vector 2Y. And we can also paint a single pixel with the setPixel functions in the same way. Then we got our fillRect function, where we can define a rect position and size, plus a color, and draw squares to the image. And then we got our bleed and blend functions to copy an image into this. So let's try that. First, let's create an export variable stamp to copy it from, and plug in our Godot icon there. Then let's use bleed rect using the stamp.getImage, the source rect, which in this case is the whole image, so from position 0 to the size of the image, and the position where to place it. But we are still not there yet. We can only copy images of the same format. So first, we need to get our stamp image and decompress it, which will take it back to our RGBA8 format. Now we just need to use this stamp image, and there is our image. You might have noticed that the corners are empty, and that is what bleed rect does. It just copied the image as is, so it has also copied the alpha values from the source image. What you most likely want to use though is the blend rect. It works exactly the same way as bleed, but it will blend the alpha values instead. And that correctly stamps the icon into our image. Finally, we also have the adjust BCS function to adjust the brightness, contrast and saturation of the whole image, if you ever needed that. And then we can also use the blend rect mask, which takes a mask image and only copies the image over the mask. But unfortunately, this doesn't partially mask alpha values. It will only hide parts of the image where the alpha is 0. So our blob here, when used as a mask, will only create a circle mask. Now that we got our basics done, let's create something cool and see what else we encounter along the way. Here's another scene. Just some mountains and a canvas. I think you can imagine where this is going. We are going to create a texture we can draw on and use that for the 3D canvas. First, let's create a sprite 2D where we will be drawing and move it to the side. Rename the node painter image and create a script. Create an export variable paint color for the color we are going to draw. And let's create a vector2i image size of 128 by 170, which is about the size ratio of our canvas. Then we'll declare the image reference, and on the ready function we can initialize it. Fill the image with white, as well as create the texture with imageTexture.createFromImage. To draw into the image, we'll create a paint texture function that receives a position. For now, this just sets a pixel with our current color, but we'll change that later. Then create the input function where we'll be setting the mouse behavior. If the event is input event mouse button and event.press is true, it is not an echo, and event.buttonIndex is mouse button left, we got our click, so we are going to draw the pixel there. But first, we need to convert the mouse position to our image position. We can get the local position with toLocal and pass in event.position, the mouse's position. But the image expands from the center of the node's position, so we need to account for that too. So our true image position is the local position minus the offset, if there is any, plus half the size. So getRect.size divided by 2. Then we call paintText with the image position. And let's not forget to update the image so we can see the results. And there we go. We can now click to draw pixels on the image. Not very useful, and we can barely see it. So let's increase the size of the drawn pixel. Create another variable named brush size equals 3. And let's replace our paint text with image.fillRect and use a rect eye at position of size 1 by 1. Then we call .grow with our brush size. This will grow the rect from the center, increasing the fill rect size. And finally, our painter color. Now we can paint big squares on our canvas. Another useful thing we can do is add color picking. So let's make the right mouse button pick the color under the mouse. We are going to split the mouse button if and add another if statement for the mouse button right. Here we are going to do exactly the same, but instead of drawing, we are going to use the getPixelV to set our paint color instead. And as easy as that, we can now grab the white color of the canvas and paint with it. But making squares and clicking all the time is no fun. So let's add the ability to draw while dragging the mouse. For that, we are going to need to check if event is of type inputEventMouseMotion, which happens when the mouse moves, and gives us how many pixels it has moved. Then we check if the left mouse button is also pressed. And here we just need to call paintText like before. Now we can finally click and drag to draw. But if we move fast enough, we get dots instead, so let's fix that. First, we are going to check if there is enough movement. Then, save how many pixels our mouse moved in our target position, which is going to be the position of the mouse on the previous frame, that is, the real position minus the mouse movement. Then, we just need to loop I num times, and update the real position with move towards the target position by 1 pixel each time, and call paintText. And just like that, now we can properly paint our canvas. We still have a few more things to do, but let's add some UI so we can change colors. In the 2D tab, let's create a panel UI. Set it to about this size, and add a H slider for our brush size. Adjust its anchor to the top, and add a label called brush size 2. Adjust the position to be below the slider, and that's about right. Now let's change the slider min size to 1 and the max size to maybe about 11, and the start value to 3. Now for the colors, create a grid container and position it about the center in the lower area. Then let's add a color rect, set it to some color, and so we can see it, open layout and set its minimum size to 25 by 25. And set the grid column to 2. Maybe let's increase the size of the rect to 35 by 35. And now you can give each square a different color. So let's set it to green, yellow, red, orange, purple. Now let me set this grid to the bottom, duplicate another color rect, and place it outside of the grid, around the top center. This is going to display our current paint color. And after adjusting it a bit, we got our paint UI. Now let's make it do something. So create a script for the grid container, and let's save a reference for the painter node. And now here we just need to connect the signal of each of the color rects inside of it, so we can change the painter color. On the ready function, for each color rect and its children, we use c.GUI_input.connect. And you can create a lambda function here with func inputs and just call the painter image.painterColor equals c.color, the color's rect color. And let's also add a reference for the current color rect and update that too. Now when we mouse over the paints, it will change the current color, and we can draw with them. But that is not ideal, so let's change it to a click instead. So let's check if the input here is a mouse button and a left click is pressed. And there it is. Our basic paint functionality is out there, but there is still a lot to improve. Instead of manually updating the current color here, let's make the painter do that. So let's add the current color to the painter script and create a setter for the paint color, so when the color changes, it will automatically update the display color on the UI. And now everything will work, even if we change the color with the right click. To finish up the UI, let's now update the brush size. So select the H slider, open the Node tab, and connect the value changed signal. And it is as simple as changing the brush size here. Now we can change sizes and paint all over the canvas. And you can cast the brush size to an int to remove the warning. The last step for our painter is now to display it on the 3D mesh. So let's add an export variable for the canvas mesh and select the canvas there. Let's create an update texture function where we are going to call texture.update and change our mesh material with the canvas mesh.material override. But you'll notice that you won't get autocomplete here. One little trick you can do is to cast the material to base material 3D, and that will make the autocomplete work again. But anyways, we just need to change the albedo texture to texture. And then let's call this update texture function instead of our texture.update after painting. And there it is, we can finally paint on the canvas. But square brushes are no fun, so to finish things up, let's add a proper brush texture for our drawings. First, let's declare an export variable brush texture. This is going to be the alpha texture for the brush. In this case, I'm just going to use a circle blob with some transparency, but it can be anything. Now we need to change our paint texture function. First we get our brush image and resize it to our brush size. Now, because the mask function doesn't blend alphas, we need to do it ourselves. So we are going to go over every pixel of the image, get its pixel, and multiply it by the paint color. This will create a brush texture of the color we want. Then we just need to call blend rect like before, but using our new brush image instead. You can use the brush.getUsedRect to get the full rect of the image. And we also need to subtract the position by half the size, so the brush stays in the center of the mouse. And now we got a proper round brush with some color fall off. But if you right click outside of the canvas, you might have noticed some errors. That is because we are trying to get a color outside of the image. So let's check if the mouse is inside the image with image.getUsedRect.hasPoint and only paint the color if that is true. What we can also do is pick the screen color if it is outside of the canvas. So if we are outside of the image area, we can get the screen color with getViewport.getTexture.getImage.getPixel at the mouse position. Now we can pick any colors of the screen as our paint and start drawing to our heart's content. But before you go, here are some extra tips and possible problem fixes. Recreating the brush each frame can be costly, so we can cache it and only update it when we need it. For that, let's create a brush image variable and create a new update brush function. Here's where we are going to resize the brush, set its color, and save it to the brush image. Then, in the paint text, we are going to use our cached brush instead. And then we just need to make sure to call update brush on the ready function once and on the paint color setter, as well as create a new setter for the brush size and call it there too. And there it is. It works the same, but now we are not wasting frames redrawing the brush every time. Also, you only need to set the texture once, so we can move the albedo texture to the ready function. And here's one problem you might encounter. While drawing this texture here, no matter where I draw, the borders of the 3D image doesn't seem to change. This is kind of a bug, but it has a simple fix. The reason it happens is because the original material used the texture with Mipmaps, and the texture we set doesn't have Mipmaps, so my best guess is that it is using a cached Mipmap of the old texture. You can solve this by setting a texture filter to not use Mipmaps, or by calling generate Mipmaps on your texture, so it does have it. But that's it. As always, if you want to support me, you can get the project files of this tutorial as well as other experiments on Patreon. Now you know how to manipulate images in Godot and create some cool mechanics for your games. I hope you liked this video, and until next time.